All right, I thought I would have some fun this afternoon. Earlier today, I looked at iteration in Python, and I thought I do the same kind of thing in emacs-lisp, so maybe we should do a side-by-side comparison. So over here we have the for loop that iterates through this list, and if we want to do this in emacs-lisp, we'll do the following. So I like to use the CL loop, which is a common Lisp like loop. So here we would say CL loop for item in a list. Here looks different. There's no commas. And then we're going to do something, and what we'll do is print the item. And that should be pretty close to the same. Maybe let's just check out the difference. So prints and print are two different versions. This is really similar to this, other than the extra carriage return in there. So this looks pretty similar to this, other than we have parentheses because it's a Lisp, and we have a different order of things, but we still have for item in, and this predates Python by a number of years. All right, let's check out the string. This one, turns out, will be a little bit different. And let's look at for item in 1, 2, 3, 4. So in Lisp, we use the double quotes. We don't get to use the flexible single quotes like we have over here. And let's do the same thing. Print item. Now this one, let me make sure we get the results. This one doesn't seem to do anything, and that's because we're using the in instead of, which works on a list, but strings are actually more like vectors. So in the common Lisp loop, we try across, and that is used for vectors. And let's see. Oh, I forgot for item. Let me make sure I didn't make something up there. So that still doesn't do anything because we do have to do it by across. And it's a little bit strange. You see these integers, and what's happening is it's iterating through each one of these and printing the character code. And so what we need to add in here is char to string, and now we should see, let's see. Char to string. Oh, I see. I need to do char to string of the item, and then we'll print that. All right, so this is going to do what we saw before over here, where we have the 1, 2, 3, and we have actually some spaces that are in here as well that aren't shown too obviously over here. All right, so that's also pretty reasonable, other than exactly what is an item in this iterable string and treating it as a vector by using the across. All right, how about this enumerate option? So remember what I did with enumerate was that we wanted to get the index and the item. So that's okay. We can do CL loop for I from 0 for item in 1, 2, 3, 4. All right, and then we're going to do this. So then I'm going to print, and we'll use format. The formatting is a little bit different here, so I'll just do %s, and then let's see, I guess I have item B in here. Let's do that second, and then %s. And then we need to put in an I, and then the first thing will be item, and then we need to say nth B. Let me make sure I got the syntax here right. Nth I of B. And now I need to come up here and define the B. So let's do, I guess I'll just use setq. A, B, C, D. And I'll just do symbols here. And so this is sort of the same. setq is basically like b equals this in Lisp, and instead of the strings, I'm too lazy to quote them, we'll use symbols, and then we'll loop for I from 0 for item in this. We'll make this formatting string, we'll put the I in here, the item in here, and the ith b element in here. Alright, so that looks like this one, so we get exactly, the same thing, and just using different syntaxes. All right, how about down here, this zip idea? All right, so we can do zip too. Let's do setq A 1, 2, 3, 4. And we can do multiple variables in here, A, B, C, D. I'll just redefine those for fun. And now we're going to enumerate and zip. So, all right, CL loop for I from 0, for A in A, for B in B, do, print, let's do the same thing I did there, list I, A, B. All right, so that should, let's see, I got a variable. Oh, there we go. So this is kind of printing the tuple, but otherwise we see the same kinds of outputs here, and we just have like these 4i starting at 0, so that increments each iteration. We get a little a from big A, a little b from big B, and then we can print those. All right, I showed you this gotcha over here, and this is not a gotcha in emacs-lisp the way we're doing this now. So if I set I to be 42 right here, and then down here print I, then it is preserved even though we have this intermediate I. So this is locally scoped inside the loop, and we don't have the same problem we had in Python. So different languages, different scoping rules. Let's see, how about this this list comprehension? So that is actually like the original way that anybody would have done this. So we can just say CL loop for X in, what do I have, 1, 2, 3, 4. Here I'm just going to collect instead of do. So what we do here is collect times 2x. So Python is an infix where you put the operator in between these two things, and in Lisp we have a prefix operator, so the times goes first and all the arguments go second. And this is exactly the list comprehension we see over here, other than we tell it that we want to do the collect, which is implied over here. And there are a bunch of other things we could do here. We could sum, we could append. There's a whole lot of options. Let's see, what else could we do? I'm going to skip this one. You can do this kind of thing, but I don't know. Well, let's try it. So CL loop for X in 1, 2, 3, 4. What if I say append? Wrong type argument. I see. So that's not going to work directly. So this is already doing the collection. Append must want to append to something. So that's not the right way to think about it. We'll skip it for now. All right, this generator, we have similar ideas here. If I look at CL loop for I from 0 below 3 do print I. that's going to give me the same thing that we see over here. So this starts from 0 and goes to a number below 3. We could change it to up to if you wanted to include 3. So that's a nice feature. If you know what you're doing, this CL loop is amazingly flexible. All right, so those are the cases for finite loops. Now let's talk about potentially infinite loops, the while loop. So there is a while loop, and basically it looks like while some test, run this body. All right, so we're going to do this one. Let's temporarily define A so we can use it, and then while greater than A1, we're going to set QA to divided by A2, and let's do this is something that you can do in the most modern Pythons, but not in the version that I have currently installed. So we can set it, and this will return the thing that's printed. And I believe, let's see, we start out with A equals 10, that's greater than 1. We divide it by 2, print it, and as long as it goes through, it should give us the same output that's over here. And I always forget the default is value. That's fun. So these are integers. So this is doing integer division because we start with an integer and divide by an integer. So Python does the default float division. So we have to do that as well. So that one looks pretty equivalent. Let's see, we can also do a while true. So let's try this version. We can do we'll start out with A is 10, and then while true. So this is we're going to have to find a way to break out of this. I'll show you what I'm going to do for that in a minute. So let's see. We'll do catch. So catch, let's say exit. So this is kind of like try except, other than we will be able to throw this tag exit in when we want to get out of it. All right, so while true, we're going to print set q a divided by a2. All right, and then if a is less than 1, or let's just say when. So another thing I like about this, we're going to throw exit true, and I think this is going to give us kind of like the same result as this one up here. So let's see. As long as we use floats. All right, so that does the same thing over here, and that we could also have this kind of if statement over here. Let's just implement that one kind of directly. Let a be 10. Let's start out I at 0, and then while true. We don't need the full if statement, so let's just do when again. When or equals a0. So this condition is actually never met. And then greater than or equal to I of 10. Then we'll throw exit, and we'll give it a value of true. So let's come up here and add our catch. All right, otherwise we're going to print set QA divided by A 2.0. And oh, we need to increment I. All right, so we'll do this generalized incrementer and do this. And this should symbols function void is name is A. Let's see, I have an A. Catch 1, 2. Let's see. Maybe. Let's see, I guess I'll just try times 0.5 here. Something is not right in the division, but I don't feel like tracking it down this second. All right, so that gives us all the way down to here, and we could print the value of I at the end if we wanted. Let's see, that would go inside the let, but print I. And there it goes. It's exactly the same. Okay, so that's a pretty easy way. This catch exit is a lot like what I showed with exceptions. All right, so let's see. Let's just check out these double nested loops real quick. These are also fine. So we write them more or less the same way. CL loop for I from 0. So we can leave that out because default is to start at 0. So let's say for I below 3, do a second loop. For j below 3, do this. Let's say print. Let's do the printing the list, and then when and equals I1 equals J1, we will throw our exit. All right, and then to make this work, we just have to wrap this in catch. All right, and so let's see, we have this is going to give us a different result than this one. Remember, this one only broke out of the inner loop, and we still see the outer loop. And so what we managed to accomplish in this one is really equivalent to using this return statement to get out of the function, but we didn't actually have to run a function because we got to throw the exit flag directly, which got us out to the end. And there is a way to do this kind of non-local exit exception handling. Let me see, help condition case. This is the kind of try except, where you have a condition case, and if you get an error, then you can handle it and kind of do other things. I hardly ever use this one, so let me see what happens. Maybe we'll just try it out. All right, so I think what we need to do here is condition case, then we need a variable executes. Let's just call it var. And then all right, so we got our error down here that says, huh? And nothing seems to have gotten printed. So I guess we need to think about how we're going to handle it. So we have our body form. And then let's add a lambda. Really flying loose here. So handlers isn't quite right. So let me see. Handlers is applicable to an error if condition name is one of the error's condition names. So I guess we need to have something like condition name body. So let's see. All right, so this is equivalent to handling all exceptions by putting true there. And then what this is doing doesn't seem to be doing anything. I wonder if I can just make it nil. Looks like it. So it looks like whenever we get this particular error because we're trying to get out, then we're just handling it and doing nothing, which is surely pretty sloppy, but it's not too terrible here for it. Anyway, those are the things that I wanted to kind of touch base on. Let me see if it makes sense in here. I don't think it makes sense to try to wrap it in a function and then try to return. There is a return statement inside of CO loop, but it wasn't obvious to me how I would use it directly in this case, and it's much easier to do the catch throw. So anyway, those are some of the ways that you can use the CO loop, and you might see a lot of similarities between the way things are done in Python. A lot of these ideas, like the list comprehension, is actually a very old idea in Lisp and emacs-lisp in particular. So this kind of syntax for making a list has been around for a long time. All right, so hopefully that was interesting and you learned something about iteration in emacs-lisp. And if you keep hanging out on this channel for long enough, then eventually you'll probably get to where you can write some emacs-lisp code of your own to do things that are interesting. All right, see you next time.